So we'll take off from where we ended off in class last week. For some of you, I even met you yesterday. That is Group C. I met you yesterday evening, okay, for your session because we could physically in class and we needed to do a makeup session online using the online platform. Now, today's class, we are looking at the concept of indices, sets, and logarithms. And depending on how far we can go or what time will allow us, okay, we may want to also go into rational functions. That is, if time permits us. If not, then the objective of the day is to stick to these three, okay? But let's see how quick we can absorb. Now, in my previous class, I introduced the concept of indices to you, and I asked you to go and learn. It was actually captured under the topic function or rules of exponents, okay? And I told you to learn them off head before you come to class to make our work much easier for us, okay? So what we will do today for indices, we are not going to copy the rules again. We have the rules. I'll just project it briefly, and then we will make use of the rules to solve, okay? Good. So that is what I'm going to do. But sets, we'll have to take it off from the very scratch. Now, so let's begin. I think these are the rules on indices, and I would like you to have it captured at your end if you've not done that already. So quickly pen it down at your end because we are going to solve examples, okay, with the rules, and we need to identify which rule is being applied. So make sure you write down this properties down. Okay. What you call as rules. First one is the multiplication rule. Okay. Then here we have the power rule. Same, we have what? A power or what? Yes, power rule also applies. Then we have what? We have the division rule here. It's sometimes written with the division. It can be written as a raised to power x, okay, divided by a raised to power y. Yes, it's even here. It's even here. Okay. So that is the division rule we have there. Then there is another one we have to also do. Let me write that down, even though that is quite obvious. Okay. We call it the zero index. A raised to power 0 is always equal to 1. So write that down. Then let's see examples of that. Now I'll touch on some few rules. Power rule means when you have a raised to power x or raised to power y, you multiply the indices. When you have a b raised to power x, when you expand, x will affect the a and then affect the b. Okay, the same way if you have a over b raised to power x, it will be a raised to power x over b raised to power x. And that will simplify further. If you have a raised to power x over a raised to power y, okay, because we have the same base, which is a, we'll take one base and then subtract what the indices. That's the power. Okay. Then any number raised to the power negative x is going to be 1 over that number raised to the power positive x. Okay, so reciprocally, any number that is 1 over a raised to the power x is going to be a raised to the power x, because that can be re-expressed. Let me do that on the left hand. That's 1 over 1 over a. So that one will automatically lead towards an a raised to the power x. So that should lead to a raised to the power x. And finally, this is the fractional index. Okay, so if you have a raised to the power x over y, it is the y root of a raised to the power x. So for example, if I have 3 raised to the power 2 over 3, it is the same as the cube root. We're saying the y root, so that will be 3, okay. Third root, that's a cube root of 3 raised to the power 2, okay. That is what the fractional index gives to us. Now let's look at some examples. I asked you to do that in class at home, because the examples slide, but I don't want to assume that everybody did it. So let's go through it in class. Now, let me just find out from you. Have your course reps posted the slides and the course outline to you? Yes, has it been done?
Yes, please.
Okay, that's fine. So if it's been done, then it means everybody should have it. Make sure you download it. Don't wait till you have a post on your page and say you did not. Make sure you have. Now moving on, we take an example. Now I'll prefer that you look on your rules, which we just copied. If you want to answer, you raise your hand so that it will be a more participatory class. Okay, for this topic, usually I let the students come to the board and solve it themselves. You look at your rules from your end and then tell me if you want to answer. Just raise up your hand. I'll allow you. Okay, but if you are not, switch off your mic. If you are not answering, mute your mic. I have Zachariah's hand up.
Yeah, so that one is the multiplication rule.
Yes, multiplication rule. So this is a who? Deborah. So Deborah, let's see how we solve it. How do we solve it?
So please, you add the powers.
Yeah, so you take one base.
Solve the building, add about
2 plus 3, which will give us, let me change my marker, which will give us 2 raised to the power
5.
Okay, well done. Very good. Now let's move on to the next example. That's we've already. Okay. So next example, what do we do here? Ibrahim Kadir.
Yes, sir.
Yes.
So this
Which
one
rule we
to
applying?
the multiplication rule.
Yes, it's the same rule. So we take what? One base.
Take one base, then we add the exponent or the indices.
Yes, so it will be 2 plus negative.
negative 6.
Okay, that will be what? 2 raised to the power. 2 raised to the power.
Minus 4.
Thank you. So now that we have 2 raised to the power minus 4, which other rule can we apply? That will be the negative exponent or negative,
Yes.
right?
Yes.
Eh.
So it's
So
1/2.
yeah, so that will be 1/2 raised
2 raised to the power 4.
to. So 2 raised to the power 4 will give us what?
1/16.
2 raised to the power 4.
It will give us 16.
16.
That is
Exactly.
2 times 2 times 2.
Taking too much. Yeah, anything.
So that gives us 16.
Yes, sir.
Yeah. Okay. Let's look at another example.
You run away, son.
Okay, what of this? Which rule are we using? Yes. Ibrahim, your hand is up.
Please, it's still the multiplication rule.
Okay, this is raising to the power.
Yes, sir.
It's raising to the power. Okay, so how do we go about it, Adriel?
Two raised to the power 3, 2 raised to the power 2.
You see, your microphones are on. So mute your mic when you are Okay, so Cadril is on the floor. I've muted all of you. If you have to come in, then I will ask you to unmute. So Cadril, you're on floor. Ibrahim. Ibrahim, just unmute yourself. Yes.
Okay. So it will be 2 raised to the power 3 plus 2.
No, this is the power rule. So this will be times 2. Look at your rules carefully.
Yes, sir. I've got it.
This one will be times 2, not plus 2. So this will give us 2 raised to the power 6. And
Yes,
2
sir.
raised to the power 6 will be 64. Okay,
Yes, sir.
thank you. Let's take another example. What of this one? If you want to answer, raise your hand. Okay, I have Techi's hand up. So Techi Paul. Adakwa. Techi Paul Adakwa. You can unmute yourself. Just unmute yourself. Paul Adakwa, I've unmuted you. So unmute yourself from your end.
Okay, sir.
Yes.
Please say still the multiplication one. So this one. Hello.
Yes, I'm listening.
Yes, sir. It's going to be 2/3 2 raised to the power -3 over 3 raised to the power -3.
3 raised to the power -3.
Yes,
That's
sir.
very true. That is very true. So if we were to simplify this, maybe you want to write it in terms of the positive. This will be equal to 1/2 raised to the power 3, right?
Yes, sir.
By
And then
divided by 1/3 raised
3 raised to the power
to 3.
3.
So this further can be simplified as, you see, because multiplication is the inverse of division. We can write 1 over 2 raised to the power 3 times
1 over
3 raised to the
3
power 3. We've changed from division to multiplication.
multiplication. Okay, sir.
So we've used the inverse, okay, from division to multiplication. So right from division to multiplication, it will change to 3 raised to the power 3 over 1. Okay. So that
Okay, sir.
whole term should be 3 raised to the power 3 over 2 raised to the power 3. Now 3 raised to the power 3 is what? 27.
27.
And 2 raised to the power 3.
8.
8.
Well done. Okay. So let's move on to another example. We have this example here. How do we handle it? Let me see a hand up. I have Benjamin Mattison. I think I saw Benjamin's hand up. He's lowered the hand. Okay, let's have Nathaniel. So Nathaniel MP. Nat. Okay. Nat. I have Techno Hoover. Okay, Techno, you're not ready. Let me mute. And then Nathaniel Entry, if you can answer the question. I'm seeing more hands. So Nat, if you can answer it quickly for us.
This is the division rule.
So what do we do?
Since the bases are the same, you pick one, that is 3, and then you subtract the exponent.
Thank you. Thank you. Très bien. This will be raised to the power 9.
Yes, please.
Okay, so this will result in
3 raised to the power -2.
minus 2. Okay, so that will give us 1
over 3 raised to the power 2.
Good. Which will be 1
over 9.
Over 9.
Yeah.
Well done. Okay. Adil Ibrahim, do you have a question?
No, sir, please.
Okay.
I just wanted to try it.
Okay. Yes. So let's see if I think there are more questions. Yeah, so how do we answer this as well? So 2 raised to the power half times 8 raised to the power half. Yes. So, Osman is here. So Osman, Sauda. Yes, Osman, do you want to try? I've unmuted you, so you can mute yourself. You can unmute yourself from your end.
Sir, please, we are using the fractional rule.
Okay, so what do we do here?
First of all, we can bring the y, which is the 2.
Yeah.
And divide it by so please, we have to find the long division. We have to find the LCM for 2 and 8 first.
No long division and LCM here. So when you look at it, whether you see 8 is a multiple of what? 2.
Yes, please.
Yes. So we can convert it to a 2 raised to the power something. Or if you like, this can also be written as, you see, the index are the same, half and half here, same index. So we could also write 2 times 8 raised to the power, the common index, which is what? Half.
1.5.
And so this is the expansion we could have. So that this will end up as 16 raised to the power half. Okay, 16 raised
Yes.
to the power half is fractional index. So that will be the square root of 16 raised to the power 1. So that is one way to do this. Another way to do it is what I said earlier. So we can change this into the power 8 is the same as 2 raised to the power 3. Okay,
Yes.
but already we have a half there. And this is 2 raised to the power half. Okay, this will end up as 2 raised to the power half times 2 raised to the power over 2. Okay, and then since we have a common base, we'll take
Just
one
add it.
and then add the exponents. So that will be half plus 3 over 2. So this gives us 2 raised to the power. That is where Sueda comes in. That's Sauda Osman comes in. LCN is, this will give us 4.
Yes, sir.
So that will be 2 raised to the power 2, which is equal to what? 2 raised to the power 2 will be equal to what? 4.
4.
Yes, please.
Same way to the square root of 16 is equal to what? 4.
4.
So these are 2 approaches which can be used to solve this example. Any question? Any question?
No, sir.
Okay, that's fine. Yeah. Yeah, so we want to try some more examples and try to understand this better. So let me clear everything on the screen. Okay. So I have, let me rather change this. I prefer to have, let me change this to a number. I want to use a number. Okay, so let's have a number here. So we're going to have 27 here. Let me have 27 here. Then let me have 32 here. Okay. So can anybody solve this for me? How do we go about this one? Yes. So let me take okay, I have Dennis. Dennis has his hand up. So whether put off your microphone, Ibrahim, put off your microphone. Then let's take Dennis. So Dennis Aja.
Okay, sir, please. We first of all solve for the one in the square root. Then we then have the power affecting the one we solve for the square root. Then we multiply through.
Okay, so tell me what to do.
Okay, so we first of all find the 3 roots 27.
Okay. So 3
That will
roots.
give,
Yes. So that will be 27.
yes, please.
Power 1/3. Okay, since it's a fractional index.
Yes, please.
Then
Then
the power 4 times 32
2 and 1 on 5.
1/5 all raised to power 3.
3.
Good. So this will give us 27 is the same as what?
So please, and come and let me solve.
3 times 3 times 3. 3, 3, 9. 9, 3, 27. So that will be 3 raised to power 3.
3.
Times
1 on 3.
all raised to power 4. Then on the other side too, we have 32 is 2 times 2 times 2 times 2.
2
So
is 2.
2 raised to power 5
Raised to the power 5
times
times
1 on 5
1 on 3.
on 5.
Yeah.
Okay, all raised to power
3.
3. So this will give us 3 raised to power 3 times 1/3 will be 1.
Yeah.
All raised to power 4
4
times
multiply
2. That's raised to power
5.
5.
So it will be 1.
All raised to power 3.
3.
So this will give us 3 raised to power.
Raised to the power
So that will be 1 times 4, 4.
4.
2 raised to power 3. Okay, so 3 raised to power 4 will give us what?
81.
81 times 2 raised to power 3 will give us
8.
8. So when we multiply the 2, what are we getting?
648.
648. Thank you very much. Well done. Okay. So with this very nice example, want to go on to a more challenging one. Let's say we have, let me clear the screen first. Okay, so Solodazi, do you have any question for me? Solomon Dazi.
Yeah, sir, please, I wanted to take it again.
You wanted to?
I wanted you to take it again.
Okay. So just observe the solution. If you have a question, then you ask.
Okay, sir.
I think it's very systematic. So just observe. Dennis, do you have a question? No, I think Dennis answered the question for us. So when you finish answering the question, you lower your hand so that I know that you don't have a
Okay.
Isaac. Isaac, do you have a question? Okay. Um, Swada, are you okay? Your hand is up.
Sir. Sir.
Yes, I'm listening.
Sir, please, this one I don't get it.
Okay, so from which side? Isa, you are writing on my screen. Yes, Swada, which side don't you start?
Please, the second one.
The second step.
Yes, please.
Okay. Yes. Okay, so what we are saying is 27. If you were using a calculator, Sweda, do you have a calculator with you?
Yes, please.
So just type 3 times 3 times 3.
Please, it's 27.
So because 3 times 3 times 3 is 27, then we can write 7 the same as 3 raised to power 3. So that is what we wrote here. So 27 is 3 raised to power 3. But you see there's already raised to power 3, 1 over 3 here.
Yes, please.
And we put that also over there. Okay.
Oh, okay.
Then 32 is 2 times 2, 2 times 2 times 2
Times 2.
2 times another 2. Okay, that's 2 raised to the power 5.
Yeah.
So that will be 2 raised to the power 5. Okay. So
Okay.
yeah, it's 2 raised to the power 5. We'll replace the 32 with 2 raised to the power 5. Okay, but the index is still there, which is 1 over 5. Then all raised to the power 3. Then you simplify. 5 times 1 over 5. 5 will cancel out 5. And 3 times 1 over 3. 3 will cancel out 3. So that is how come we are getting 3 raised to the power 1. Then 2 raised to the power 1 here. Are you okay now, Sweda?
Yes, please. Thank you.
Isaac, are you okay now?
Yes, sir.
Okay, that's fine. Good. So we want to move on to another challenging example.
Someone is saying,
Let's try. Alex, you are writing on my screen. So let's try. You try this example for me. So the first one I'll put out there will be, question 1 will be 81 over 256 all raised to the power all raised to the power of 4. Miracle, you are writing on my screen. Okay. Then the next question will be 25 over 49 raised to the power negative. Please mute your microphones. Mute your microphones. Okay. What did I just do? So these are the two questions I would like you to try. Then I have another example here. This one we'll try in class. So for these two, try them on your own at home. Then for the next one, which will be the third question, that will solve in class, because I want to give you a similar one to try at home. So we have 27 raised to the power n, okay, plus, or let me say minus 6, okay. You let me just add plus 2 to it, and then 6 times 3, 6 times 3 raised to the power 3n plus 3 all over 3n times 9n plus 2. Yeah, so this time we have a much bigger problem at hand, but will be solved with the same what? With the same rules, okay? So think through it and let's see if we can solve it. This is 9. Look at it carefully and let's see how best we can solve that problem. Yes. Okay, I already have 3 people hand raised up. So I have Dennis. Dennis has spoken. So let me give Nathaniel. I think no, this time Nathaniel entry. Yes, Isaac. Okay, let's have David. David Adabla. So David, your hand is up.
Okay, so I think the powers, before we deal with the powers, we have to make sure the identities are having the same numbers.
Okay. Yeah,
So maybe for 27, that'll be 3 to the power 3.
Okay. So
Yeah.
3 to the power 3 for 27. Put it in brackets.
Yeah.
1 raised to the power n
Plus
plus
2.
2.
Yeah.
Okay. Minus
Is it 6.3 or just 6?
It's 6 times 3 raised to the power.
Okay. Okay. Then for the 6 to, that'll be the 6 will be, I think, 2 to the power. I'm coming.
It will be 2 times 3.
Yeah.
2
2 times 3.
2 times 3 times 3 raised to the power 3
plus 3.
plus 3.
Yeah.
All over.
Then we come to the base.
Yes.
Okay. So we repeat the 3n.
Okay, so this will give us 3n.
Yeah.
Times
3 to the power 3. 3 to the power 2, sorry.
3 to the power 2.
N.
All raised to the power n.
N plus 2.
So what's next?
Okay, So now for the first 3 to the power 3,
Yes, the power rule. So this 3 will multiply
multiply, yeah,
that
the
outside
n plus,
bracket. You
yeah,
understand?
yes, please.
The same way this will also come in. So we're going to have 3 raised to the power into bracket n plus 2 minus 2 times. You see, this is 3 raised to the power 1. So since we have common base, we'll take one of them and then add the exponents. So this will be 3 raised to the power 3. Then this will be 1 plus 3n plus 3. Then, yes, what do we do next? Yes, Dave. Okay, I think it's gone off. So let's have Bernard. Bernard, continue for us.
Yes, sir. And also with the denominator, they also have the same base. So we pick one base and add the
Let's simplify this before we do this one. Yes.
okay. Okay, so it will be 3 raised to the power 2, 2n plus 4.
Yeah, so this side will be 3 raised to the power.
3 raised to
No, I want us to
2n plus 4.
let's take it systematic. So we know it will be multiplying. So 2 times n plus
Yes, please.
2. Okay. After which we'll begin to expand.
N plus 2.
Expansion. So this will be 3 raised to the power what?
3n
3n
plus 6
plus 6. Minus
minus 2 times 3n plus 4.
3n plus 4.
Plus 4.
Or because we are adding 1 and 3. Okay. That will give us 4. Okay, all over
4.
This will give us 3.
Yes. Yes, sir. 3, yeah.
Okay.
3 raised to the power n times
3 raised to
2n plus 4.
2n plus 4. Okay. So for the denominator, I'm going to continue in the next step, okay? But let me bring the next step here, okay? I'm going to bring the next step here. So take note of that.
Okay, sir.
Okay, so that is equal to 3 raised to the power 3n plus 6 minus 2
3n plus 6
times 3 raised to the power 3n plus 4 all over.
all over. We pick the
base. Now
common base. Yes, sir.
we take one
And we add
the exponents. So
exponents.
plus 3n
Plus 2, 3n,
and
2 and yeah, plus 4.
good. That is nice. Now, what next? We could further simplify what we have. Okay, we can further.
Yes, sir.
So when we look at this carefully, for the lack of space, you see n plus 2n will give us 3n. Okay, n plus 2n will give us 3n. So I'm going to clean this one and then write 3n there. So this is 3 raised to the power 3n plus 4. Okay, good. So this expression can also be written as 3n, so sorry, 3 raised to the power 3n, okay, times 3 raised to the power 6 minus 2 times 3 raised to the power 3n so that will be 3n plus 4. No, sorry. I want us to see it for factorization. So that will be 3n times 3 raised to the power 4 all over 3 raised to the power 3n times 3 raised to the power 4. That's interesting. So when we get to this stage, clearly we can see that we have a 3 raised to the power 3n here, 3 raised to the power 3n here, and 3 raised to the power 3n over here. So which means that if we can factorize 3 raised to the power 3n, we can so much simplify the term we have there. Then again, we also have 3 raised to the power 4 here. This 3 raised to the power 6, which can be expressed as 3 raised to the power 4 plus 2. Okay, and then this is also 3 raised to the power 4. So that too could be simplified. Okay, so let me give you some time, brief time. Write down the expansion we have done so far to this point so that I can clean the right hand and then we'll continue. So write down what we have done so far. So I can free some space for us to continue. Okay, so I'm going to clean this section. Yeah, so looking at this is the same as we said we'll factorize. So let me do that up here. So 3 raised to the power 3n will come out, which means if we bring this one outside the brackets, then we'll be left with this term in, which is 3 raised to the power 6. Even at this point, let me re-express this. This is the same as 3 raised to the power 4 plus 2. 6 is the same as 4. So minus, we have 2 times. Now we brought out the 3 raised to the power 3n. out of the bracket, we factorize it. So we are left with 3 raised to the power 4. Yeah. All over. We bring the 3 raised to the power 3n outside the bracket in the denominator term. So we are left with 3 raised to the power 4 in the bracket. If that is the case, then it means that we can easily cancel out, since we have like term. 3 raised to the power 3n can cancel out 3 raised to the power 3n. Is it clear to everyone? If it's not clear to you, you can raise up your hand. So Vincent.
Okay. Good morning. Sir, please, how did you get the 3 exponents 4 plus 2?
So 6 is the same as 4 plus 2. 6, 4 plus 2 equals to what? 6.
It's exponent.
Okay. Listen, your network is not too stable. Osman Sauda. Osman, your hand is up.
No, I was about to ask the same question.
Okay. Isaac. Isaac, your hand was up. Isaac, you can mute yourself from your end. Okay, let's take Bismarck. Bismarck.
Yes, sir.
Nyako.
Sir,
You have a question?
sir, please, I also don't get aside.
Come again.
Sir, to where, like, where you had a 3 to the power 3 and I don't get that.
3 to the power 3n. Oh, okay. Let me just demonstrate with an example, okay? Let's say you have a times maybe x, then minus times a times, let's say, b all over a times
expanding this,
you get, you see, because you have a here and you have a here, you can factorize. You just factorize and bring the a out. If you bring a out, you'll be left with x here minus 2b, okay, all over a into bracket c. So then you can cancel out the common term. Okay, so that is how we brought out the 3 raised to the power 3n. Have I answered your question for you? Mohammed Jan. Mohammed Jan. Ivan says he's Evans. Mohammed Jan and Evans. I think I have somebody with Galaxy tab. Oh, where is he? Galaxy tab. Galaxy tab. Raise up your hand again. Let me unmute you. There you. Bismarck Nyako.
Yes, sir.
Yes, anything.
Please, you've written 3 to the power 4 plus 2. I mean, you expanded the 6.
Yeah, 6. 4 plus 2 is 6.
Okay, okay.
Okay.
I understand.
Yes. There was one Evans. Evans, where are you? I want to be sure you are okay now.
Well, no, man, I'm not okay. Oh.
Yes. Is it Evans who just spoke?
No, sir. This is Isaac.
This Isaac. Isaac.
Yes, sir.
Evans,
Sir.
I unmuted you. Speak.
Hello, sir.
Yes.
Sir, I'm Evans.
Yes, go ahead.
Sir, I was lost.
But you're okay now.
Yeah, I think I'm okay now.
Okay, that's fine. Okay, so Isaac, let me take your question.
My problem is where the you cancel the how you manage to cancel the 3 raised to the power 3n over 3 raised to the power 3n because that is where I had a confusion.
Yes, and I demonstrated with an example. So if you have a times x minus 2a times b, there is a common term which is a here and a here. So you can bring that outside. Then if you have ac, a is also common, so bring that outside. So once you have common terms, then you can cancel this and this out. A goes into a 1 times.
Okay.
So the same way, if you have 3 raised to the power 3n and 3 raised to the power 3n, 3 raised to the power 3n will go into 3 raised to the power 3n 1 time.
Okay. Okay, sir. Thank you.
Okay. Somebody just raised the hand. Ketura Tete. Tete Ketura. Okay, Ketura is not speaking. Daniel Apia.
Yes, sir. Sir, please, the part which is the 3 to the power 4 plus 2.
Yes.
Sir, please, you could do it 3 to the power 3 plus 3. So why choose 4 plus 2?
Yes. Well, look at the remaining terms where you see there is a 3 raised to the power 4 here. There is a 3 raised to the power 4 here. So
yes, please.
next step, I'm going to also factorize those. That is why I made it 4 plus 2.
Okay, sir. Okay. Thank you very much.
You're welcome. Okay, so having understood to this point, we will continue. So which means now we are left with 3 raised to the power 4 plus 2 minus 2 times 3 raised to the power 4 all over 3 raised to the power 4. Okay. Good. Having said that, 3 raised to the power 4 plus 2 is the same as 3 raised to the power 4 times 3 raised to the power 2 minus 2 times 3 raised to the power 4. Now, if you have your hand up, kindly put it down first. Then all those who have their hands up and are not asking questions now, please put down your hands so that we'll be left with Only those who have what questions to ask. If you don't have a question, lower your hand so that I can clearly see those who have questions. Captain Clark.
Sir.
Yes.
Sir, please, with the 3 raised to the power 4 plus 2.
Yes.
Why didn't you add the 4 plus 2, making 6? But rather, I don't understand how you did that place. Why can't we add the exponents?
Clark, it was already 6. But you see, there are terms 3 raised to the power 4.
Okay.
So that is what your colleague asked. Why didn't I make it 3 raised to the power 3 plus 6? It's because I want to factorize the 3 raised to the power 4 out. You see, that is why I broke it into 4 plus 2.
Okay.
So having said that, this is going to, now you can see it is common here. 3 raised to the power 4 is here. 3 raised to the power 4 is here, and 3 raised to the power 4 is here. So we can factorize that as 3 raised to the power 4.
Okay.
3 raised to the power 2. If we are left with as 3 raised to the power 6, it will be difficult seeing why I'm factorizing 3 raised to the power 4 out.
Yeah.
So over 2 all over 3 raised to the power 4. Okay. Yeah, so which means that 3 raised to the power 4 will cancel out 3 raised to the power 4 once.
Power 4, yeah.
And then we'll be left with 3 raised to the power 2.
3 raised to the power 2 minus
2. And 3 raised to the power 2 is 9.
9.
9 minus 2 will give
us 2. 7.
So the final answer is 7.
It's 7.
Yeah, so it's so interesting. We have this complicated expression here, and the final answer is just a single number, which is 7.
Yeah.
Quite exciting. Okay. Yeah, that is very exciting once we have the knowledge of indices. Very, very exciting. Okay.
Yeah.
Yes, let me see if there are some hands. Darko Obi. Obi Darko. You can raise your yes. Speak.
Hello, sir.
Yes, go ahead.
Sir, please, I have a problem with the starting of the work. The 6 times 3 raised to the power 3 and plus 3.
Yes.
Yeah, when we simplify that one, we got 2 times 3 raised to the power 1.
Yes.
Times raised to the power 3 and plus 3.
Yes.
Now, my question is, how come we got 3 raised to the power 1?
Yes, 6 is the same as 2 times 3. 2 3 is what? 6.
Yes, sir.
Yes. So 2 times 3 is 6. 3 is already raised to the power 1.
Oh, okay. Okay, thank you, sir.
You're welcome. Isaac, do you have any other question? Isaac,
Later, please.
Then lower your hand. Lower your hand.
Okay, sir.
Osman Sauda. Osman.
Please, no question.
Okay, so lower your hand. If you don't have a question, lower your hand. Emmanuel J. Akosi, if you don't have a question, lower your hand. Vincent Ado, if you don't have a question, lower your hand. Darko, lower your hand. Asari, Emmanuel, yes, I'm seeing you for the first time. Asari. Asari, I've unmuted you.
by the factorization method.
Sorry, I've unmuted you.
Hello.
Yes, I'm listening.
Hello, sir. I wanted to ask if we didn't go by the factorization method from the 3 raised to the power 4 plus 2. And we just added the 4 plus 2 and simplified it. Is it wrong or something? Hello. Hello.
Oh, sorry. That was, I think Ibrahim was on the platform. Hello, Ibrahim.
Yes, sir.
Was it Ibrahim? Somebody asked a question. I allow somebody to ask a question.
Yes, please.
Yes. What was the question about, please?
Please, when you reach 3 raised to the power 4 plus 2 minus 2 times 3 raised to the power 4 all over 3 raised to the power 4.
Yes.
Also, cancel the 3 raised to the power 4 with the 3 raised to the power 4, the denominator. Can you also do that?
Your voice is a bit low. I got your point. You were saying that you have a problem here, but you have to speak a bit louder.
What I was saying, I said, can we also cancel that numerator, which is 3 raised to the power 4 with the 3 raised to the power 4, the denominator?
Aha, good. Thanks for your question. Now, in class, you see, you are from different backgrounds, and I'm fortunate to have taught all such backgrounds before. I've taught at the senior high level before. So I know some of the challenges and the problems, some of the basic mistakes students make. So at this point, okay, this type of cancellation where you immediately want to cancel 3 raised to the power 4 is here, so let me cancel this and cancel this. Please avoid it. It should not be done under any circumstance. Try and avoid it. If you want to cancel, factorize like we have done. Make sure you factorize, have the common term in the numerator and the denominator before you do your cancellation. Don't try to cancel when you have not factorized. Okay? Some of you want to do it quickly. It can be done, but anytime students do that, you most of the times get it wrong. So avoid that. Make sure you factorize before you do your cancellation. Okay? So that is my response to your question. Just avoid that step. Don't apply it. Make sure you always factorize. Go to this step, factorize before you cancel out. Very important. Yes, I have who again? Kelvin Cyril. Kelvin Cyril.
Yes, sir.
Yeah.
Yes, so I was asking a question that is it necessary to always bring the point than to bring in a multiplication sign?
Yeah, so you can change it to multiplication sign. That's okay.
All right, sir. Thank
Yes,
you.
but in exams, take note. Sometimes a point will be brought. So when you see, you don't think it's a decimal number. Okay.
Okay, sir.
Okay. I think we've had a lot of questions. So let's move on. We have 3 topics to look at, like I told you. So let's go on to the next one, which will be on sets. I think there is a final type of example. Let's do that quickly and then move to sets. Okay, no, I'm not interested in this. Yes, something like exponential equations. So when we meet this type of problems too, we should know how to handle them. All you need to do is to change them, both the left and the right hand, to a common base. Okay, then you equate the powers since the base are the same. So for example, 5 raised to the power x is equals to 125. How do you go about it? Change 125, okay, as an exponent of the base 5. 5 times 5 is 25. Times 5 will give you 125. So it means 125 is 5 raised to the power 3. Okay, so we can easily change this as 5 raised to the power 3, which implies that since our bases are common, then our exponent should also be what? The same. So it implies that x is equal to what? Is equal to 3. Good. That is how you solve such a problem. Now let's look at another example. Sorry. So in this example here, we're asked to what? We're asked to solve 7 raised to the power x minus 1 equals to 7 raised to the power half. Here clearly we can see that the bases are the same. So it is the exponents. If the bases are the same, then the exponents will also have to be the same. Okay, good. So all we need to write is the exponent on the left hand term is equal to the exponent on the right hand term, which is x minus 1 is equals to minus half. Then you make a change of subject. Okay, change of subject means we want x alone on the left hand. If that is the case, then we have to bring what? 1 to the other side. Okay, at the lower level, you are just told send 1 to this side, and then the sign will change to plus. But technically, what we are doing here is we add 1 here, and then we add 1 here. So once we add 1 here, minus 1 plus 1 will be 0. So we'll be left with x is equals to minus half, okay, plus 1. And then 1 is the same as 1 over 1. So this will give us, this is where your LCMs come in. So this will be 2, LCM 2 times 1 is 2. 2 goes into 2, 1. And then times the numerator will be minus 1 plus 1 goes into 2, 2 times the numerator here, which will be 2 times 1 will be 2. So this will give us what? 2 minus 1, which is 1 over 2. So the final answer is going to be equal to what? Half. So x is equals to what? X equals to half. Okay. Yes. So I'm seeing some additional hands up. Let me take Wahab. Wahab, for the first time seeing you. So Sorry, Wahab. You can mute yourself now, or you can unmute yourself. Sorry.
Yes, sir.
Yes.
So please, so you said if the bases are equal, we take the exponents, right?
Yes, if the bases are equal, then the exponents are also equal.
Okay. So sir, please, I'm having a problem with where the x stands alone and then the one travels from the equal sign to the other side for the LCM there, yeah, for that portion.
Yes. So this is what we call change of subjects.
Okay. Okay.
So if 2 people are in a room And I said, let Kojo alone be in the room. Let's say
Okay.
Kojo and Amma are in one room, okay? And there is another room here. I said, let Kojo alone be alone in the room.
Okay.
Okay,
Sir.
Amma has to leave the room and go to the other room.
Yes, please.
And that is what we mean by change of subject. So to do that,
Yes.
basically just add one.
Yes, sir.
Take away the negative one here. But on the right side, you will find that one is there. Okay. Yes, let me take, I have one hand, Bernard's phone. Bernard's phone. So let me take your Bernard's iPhone. Take your question.
No class.
Bernard.
Yes, sir.
Yes, your question.
I want to ask. Negative 1 over subtract the half, or you still need.
Bernard.
Yes, sir.
Problem is all the way from JHS3. Okay, when you see, some of us, when we see negative 1 plus 1, we find it a problem. But the moment we see 1 minus half, it's not a problem to us.
Yes, sir.
Yes, that should not be a problem, okay? Minus half plus 1 is the same as 1 minus half. What it means here, what it means is you have one loaf of bread.
Yes, sir.
Somebody came to you. That is what it means. Then here in this context, somebody is having one loaf of bread and then you are taking half from it. Or you can say that you did not have half loaf of bread, or you owe somebody half loaf of bread, and then somebody brought you one loaf of bread. It means that you'll be left with half. Is that also? If you were somebody half and somebody has brought you one loaf of bread, you pay back your half and be left with half loaf of bread. In the same way, if you had one loaf of bread and somebody came for half, you will still be left with half loaf of bread. So in other cases, they are the same. So don't worry yourself when you see negative 1 over 2 plus. Work with it as it is. If you are not comfortable with it, you just rearrange. This is the plus 1. We'll bring the plus 1 first, minus the half. Okay. But in rearranging, you see, sometimes the rearranging causes problem for some people. So I'll advise you rather keep it as it is and work. Just follow your rules and your expressions and work, and you'll be just fine. Okay. Okay. Yes. And your link is, let me take a Cosby Awidi. Awidi, you can unmute yourself.
Hello, sir.
Yes, go ahead.
I wanted to ask, what if the bases are not the same?
We'll come to that. We'll come to that. Because we want the bases are the same. We'll do that when we get there. I think the questions are enough. Let me go on to the next example. Yeah, so the same way here, 8 raised to the power x is equals to 2. 8 is the same as 2 times 2 times 2. So that will be 2 raised to the power 3. Okay. So here we have 2 raised to the power 3. 8 is the same as 2 raised to the power 3. All raised to the power x is equals to what? 2. 2 is the same as 2 raised to the power 1. Okay, so here we have 2, then we apply power rule. So you multiply the index 3x is equals to 2 raised to the power 1. Then, since the bases are the same, our exponents will also be the same. So which implies that 3x is equals to what? 1. Okay. And we want x on one side alone. So you divide both sides by what? 3. That should 3 will cancel out 3. And then we'll be left with x is equals to 1 over 3. That will be your answer. Okay. Bismarck Nyako. Bismarck Nyako.
Yes, sir. Sir.
Yes, Bismarck, go ahead.
Sir, please, I'm okay. I was asking for the example we solved earlier, but you didn't.
Okay, that's okay, Bismarck, that's okay. Okay. Then David Adabla.
Okay, sir, please, I wanted to ask a question.
Yes, go ahead.
Please, assuming the 2 had a power,
yes,
which was 0.
2 had
which
a
was
power
0.
of what?
0.
0.
Yes, please.
Okay, yes.
How will we go about that?
Just follow the same procedure. So 2 raised to the power 0. This will be 0. This will be 0. Just a minute. Let me. Yes. I'm saying just follow the same steps. So when you follow the same steps, it means that x will be what? X will be 0. Okay, of course. Now let's try and interpret it and see whether it makes sense. 2 raised to the power 0 is what? Yes, class, tell me. 2 raised to the power 0 is?
1.
It's 1. 2 raised to the power 0 is 1. So if you have 8 raised to the power x and you found x to be 0, 8 raised to the power 0 is also what?
1.
It's 1. So 1 is equal to 1. Do you see? So in mathematics, you see, when you see the question, just follow the process. Just follow the procedure. Don't be bothered about how the question is looking. Apply the rules and you will get the answer. That's all.
Thank you.
Yeah. Good. Yes, Alex, your video is on. I've stopped it anyway. So Alex, let me have you unmute yourself and then ask your question.
Please, I'm okay now. Like I wanted to ask the same question, but you have answered.
Okay, that's okay. Elijah Abbey.
Yes, sir. How come you got the 3?
8 is the same as 2 times 2 times 2. 2, 2, yeah. 4. 4 times 2, 8. So 2 raised to the power 3 is 8.
Okay.
Okay. That's fine. I think enough of this particular example. So let's move on to another. So I'll clear the screen. Okay. So we've looked at this. Let me see. So when you examine this one too, okay. Yeah. There was another example I put out. Yeah, so just examine the examples on your slide. So you just examine it. Now, this is also another very exciting one. Okay, this time, somebody asked, what if the bases are different? We'll come to that, okay? We need another knowledge. That is why you don't have a question like that here now. Now, if I give you this question to solve, It looks like a quadratic equation, but it is not. Okay, it's not because this is an exponent here. 2 raised to the power x is an exponential function. Okay, and then this is also exponential, so it is not algebraic. Okay? If it was algebraic, then you could have had 4x or 2x squared plus let's say 5x, okay, plus 2 is equal to 0. Then I ask you to find x, but it is not algebraic. This time it is exponent, but it looks almost like this. It means that it is more or less in that form, right? Just that it's expressed in terms of exponential function. So what we can do is, to make it very simple for us to solve, we can let y or any letter represent this exponential function, which is 2x. So we are saying that let y be equals to 2x. If we make y equals to 2x, then it means that wherever you are seeing 2x, okay, is going to be y, and then this side too is going to be y, okay. Then the squared will affect the y. Don't forget about the square here. Okay, so it means we'll rewrite our function as what? 2 into bracket y squared minus 5 into bracket y plus 2 is equal to what? Is equal to 0. Okay, so that will lead us to this equation here. Okay, and to solve that algebraically, this is a quadratic expression. So first you multiply, you find the product of the coefficient a and c, which is 4. So that is 4. Then you find two numbers, which one you multiply, you get 4, but when you add, you get your minus 5 here. Okay, so that should give us, when we factorize, we'll end up getting, let me check our example first. 4 will give us 4 and negative 4, okay, and negative 1, okay. So for negative 4 and negative 1, when we multiply, will give us what? Give us positive 4. Okay, but when we add, we'll get, when we add them, we'll get negative 5. Okay, so which will help us to re-express what we have here as 2y squared minus, if you like, 4y minus y, that is 1y, the factors which we just found, plus 2 is equal to 0. So this will end up giving us, we want to group them. So when we group, we'll get 2y squared, okay, minus 4y. Then when we group this side, we bring the negative out and group it. This will give us 1y, okay, minus 2 equals to 0. Please follow carefully. Pay attention and stop raising your hands. Okay, so now we can factorize. This will give us 2y, so we are left with y here, minus 2 Then we have here, we have what? There is no common term there. That will be just one. So we have y minus 2, which is equal to 0. And then when we refactorize, we get 2y minus 1. Okay, times y minus 2 equals to 0. Okay. So on that note, we can solve for y. This will be 2y minus 1 equals to 0, which will imply, and when we take this, we add 1 to both sides. Okay, we'll end up with 2y. This will give us 2y equals to 1. Okay, and then when we divide both sides by 2, we'll get y is equal to 2 will cancel out 2 here. So we'll be left with y is equal to half. And at the same time, too, if we solve the other side, y minus 2 equals to 0. Okay, we add 2 to both sides, add 2 here, add 2 there, and then you get y is equals to 2. Y equals to 2. So the solution is y is either half or y is equal to 2. So this should be all. So y equals to half or y equals to 2. But we said that y is equals to what? 2 raised to the power x. So we meaning that 2x is equals to half, or 2 raised to the power x is equals to 2. Okay, so then you can solve for your x from this step. Now, in solving for your x, because we don't have space, let me take your questions, answer them before I continue. Yes, Daniel Apia.
Okay. So I'm okay.
Okay, that's fine. Lower your hand. Lower your hand for me. Alex Owusu.
11 to 2.
Isaac, sorry, Alexander Isaac. If you're okay, just lower your hand for me so that I don't end up spend time calling.
Hello, sir.
Yes, Isaac.
Yeah, sir, please. The four, no, the four you wrote it. Like I don't understand. The 10 is 5 by you wrote 4. The second step. So I want you to go over there again.
No, I'm not going over again. Isaac, when you are solving quadratic equation, the first step is you multiply the coefficient of y squared with the constant here. So 2 times 2 will give you 4. That is where we got the 4 from.
Yeah.
Okay. So after you've obtained the 4, you look for 2 numbers, which when you multiply will give you 4. But when you add, get the minus 5 here. Okay. So that is exactly. So when you take -4 and -1 and you multiply, you get the 4. But when you add, you get -5.
Okay. Okay. Thank you.
You're welcome.
Okay.
Yeah, so lower your hand for me.
Okay.
Let me clear the screen and then continue the solution. Okay. So, which means that if we get to this point, this is the same as 2 raised to the power x is equals to 1 over 2 is the same as 2 raised to the power what? -1. So your x will be what? -1. Okay, you have to write it. So x equals to -1. Since we have the same base, then here 2 raised to the power x equals to 2 is the same as 2 raised to the power x equals to 2 raised to the power 1. So here our x is equal to what? Is equal to 1. Okay. So that is how we get the value for x. Okay. Now, for a number of you, I'm sure you still have some 1 or 2 problems with solving the quadratic expression. That is why I took my time to go through systematic. Okay. So I'll make the video accessible to you, available to you, so you can follow the steps and then solve more examples, please. When you know you have a weakness, don't wait till we get to a problem and then you complain about the weakness. I think with the first step, you should follow suit and then solve more examples on your own before what you come to class. Okay. We are done for quadratic expression in what just happened. Please, if you have your video on, put it off. Put the video off. If you have your video on, please put it off. We don't need to see you. You need to see the screen, not the other way around. Okay. Joshua Buffalo, put your video off. Nicholas Fosu, put off your video. Okay. So in the next stage, we are going to look at sets. Okay. And for sets, when we talk about a set, we are talking about the nth root of, let's say, a prime number, okay, or 2. So we have the square root of 2, the square root of 3, the square root of 5, the square root of 7, square root of 11, etc. Okay, such square roots are called sets. So we generally write them as the nth root, okay, of a certain number. When it is irrational, we say it is called a set. S-U-R-D. Okay, so we are looking at sets. Okay, so all we're going to do here is to look at operations on what sets, how to add. Our objective is how to add and to multiply, add or subtract, and also to multiply or divide what? Or divide sets. Okay, so multiplication of sets. That is our objective. Okay, so let's take some examples and then see how it works. So example 1, we are asked to simplify. In our first example, we are to simplify. So simplify 5 root 3. This is 5 times root 3, plus 4 times the square root of what? 3. Okay, so take note. There is a difference between having this. Sometimes you put the number ahead of the square root, inside that v of the square root, and then 2 times the square root. They are different. Okay, this means multiplication. This means the square root of. So if I put 3 here, this means the cube root of. But if I put 3 here, this is 3 times the square root of. Okay, so take note of those. Yeah, so to solve our expression here, all we need to do is we can factorize. Okay, we can factorize. Once we factorize, you see we have square root of 3 here, square root of 3 here. Okay, so this can give us, we can have the square root of 3, okay, out, and then we have 5 plus what? Plus 4. Okay, now the next thing to do is we solve what is in brackets. That will be 5 plus 4 is 9. Okay, but usually you write that in front of the set. So that will be 9, and then we have root 3 will be our final answer. It's quite simple. So in further examples, what we'll say is if you have the same word set, all you need to do is to add the coefficients. You don't need to go through this stage again. So just like the basis, take a set if it is the same, and then add these 2, which will give us what? 9. Okay. So we can move from this stage to this stage. Let's take another example. We want to simplify 7 root 2 plus 4 root 2 plus 11 root 2. So I'm going to open the platform for you to answer that for me. So I'll take Ilyasu Musa Ilyasu, give me the answer. Ilyasu, you can unmute yourself. Oh, we can't hear you. Okay, let me take another person. Richard Kumar.
Yes, sir. Sir.
To be the answer.
Sir, 11 square root 2.
It will be all.
11 square root 2.
No, we have 3.
Hey.
I said you should add.
Okay, sorry. It will be 22.
Okay, 20. So that will be 7
square
plus
root 2. 4 plus 11. Into bracket square root 2.
Yes. So this gives us 22.
22 square root 2.
This is correct. Well done.
Thank you, sir.
Okay. Now let's take one on subtraction. Subtraction is just like the addition. So you follow the same rule. So if you have 4 root 2, this is simply going to be 7 minus 4, okay, in brackets, and then square root of 2, which will be 5 root 2. Okay, having said that, we want to go on to more challenging examples, okay, to make sure we really understand what we have just studied. So let me clear the screen and let's take another example. I have a question here. We have to simplify question 1, which is square root of 18 plus 2 root 50 plus, no, I have minus 7 root 2. Okay. Now, how do we go about this problem? The rule here is we need what? A common set. And then we said that sets were also the square root of what? Prime numbers. Prime numbers means that they cannot be broken further, okay, except for themselves and 1. So 2, there are no 2 numbers that can multiply to give you 2. No 2 numbers to multiply to give you 3. No 2 numbers to multiply to give you what? 5, except 5 and 1. Okay, that is what we mean. But 18 can be broken down. Not what? It's not a prime number. Okay, 50 can also be broken down. Now the objective here is because we will be adding them, the idea is you have to break 18 down into 2 numbers so that you have a 2, so that we'll end up with a common base of 2, which we'll be adding in the long run. So what 2 numbers will help us to get that? 18. If I want 2 numbers which multiply to give me 18, or 2 times what number will give me 18? Yes, class. So Isaac, 2 times what number will give me 18? Yes, that will be 2. That will be 9. So we have 2 times 9 will give me 18. Then plus 2 times what number will give me 50? That will be 2 times 25. Will give me 50. Then I have my 7 root what? Root 2. Okay. So what next? This can also be re-expressed as the square root of 2 times the square root of 9 plus 2 times the square root of 2 times the square root of 25. Then finally minus 7 root 2. 7 root 2. Okay, so we are inching closer to having what? A common set. Okay, we are inching close to having a common set. So the question is, what next? Now, very simple. Square root of 9. 9 is the same as 9 raised to the power 2. Okay, and the square root itself is raised to the power half. So 3 raised to the power 2 times half will be 3 raised to the power 2 times half from the indices we just learned, okay, which will be equal to what? 3, because 2 will cancel out the 2. 2 times half will be 1. Okay, the same way 25 is also 5 raised to the power 2 is 25. Okay, so square root will be times half, meaning that we'll get 5 from there. So let's clean that section and then rewrite our expression. So this is going to be, this one was 3, the square root of 9 is 3 root 2, then plus, we have 2 times, the square root of 25 is 5. So 5 root 2, then minus 7 root 2. Okay, this will be the same as 3 root 2 plus 10 root 2 minus 7 root 2. Okay, so that should give us 3 plus 10 minus 7 in brackets without root 2, which is a common set. So 3 plus 10 is 13 minus 7 will give us 6, 2 as the final. Okay. That is nice. So we will also try another example. We have, I think the next thing we'll look at will be on multiplication of sets. We want to multiply sets and then quickly look at rational sets. Then we can look at logarithm. Let me take 1 or 2 questions if you have that. Okay, I think Richard Kumar, I've unmuted you.
Yes, sir. Sir, please, you see the square root 18?
Yes.
Yeah. Sir, please, what if you're gonna start, you can start with 9 square root 2, then plus 2 times 5 square root square root 2, then negative minus 7 square root 2, without using 2 times 9 square root 2 plus the first solution you made.
No. If you say 9 square root 2, this is 9 square root 2. Is that what you are saying?
Yes, please.
No, this is not the same. It's not the same as 18. It's not the same as square root 18.
Okay. That's it.
The square root of 18 will give you 4 something. That should give you 4.3.
4 square root.
Do that on your calculator. The square root of 18 gives you 4.33 something.
Okay.
Have you done that?
Sir, please, I'm coming.
Use your calculator, I see. Richard, you are keeping long. Have you done?
Say, sorry. Oh, it's a mistake somewhere.
Square root of 18 gives us what?
Sorry?
Square root of 18. Can somebody give square root of 18?
I said it was 4.22 something.
4.24. 242.
Yes, please.
Okay. Now 9 times
9 times what?
The square root of 2 will give us
12.72.
So you can see clearly that 9 square root 2 is the same as 4.24.
Okay, sir.
They are different things. Okay.
Okay. Thank you.
You're welcome. Okay, so now let's look at the multiplication of sets. We want to look at the rules which should help us to go to division, rationalization. Okay, so in multiplication of sets, we have 3 rules which we will follow. A times the square root of B will give you this one. We've even just looked at it. That should give us what? That should give us A, B. A times B. Then if we have A square root B times D times the square root of D, it is going to be, you multiply your coefficients, which will be A and C, AC, and then you multiply the root 2, we have BD. Then square root of A times the square root of A is going to be equal to that will be A squared, which is equal to A. So we take note of that. Now let's try. I'm going to try one example, then I'll leave the next one for you as an assignment. Already I've given you 2 questions as an assignment. Okay. So we are to simplify 5 plus 2 root 2 times 2 minus 3 root 2. Okay. So in our solution, so this should be more appropriately. So this 5. Yeah, in our solution, all we do is we need to expand the bracket, okay? So this times that, I think somebody even wants to answer. And then this times this. So we can either expand the brackets like this. 5. I like expanding multiplying straightforward, okay? So we have 5 times 2. So 5 times 2. Then we bring the sign here, minus. Then we have 5 times this. So that will be minus 5 times 3 root 2. I've already brought a sign, okay? So no need for me to put a negative in front of the 3 root 2. Then once I'm done, I'll do the next set of multiplication, which will be plus. Then I'll multiply this and this. Okay, that's 2 root 2 times 2 will be 2 times 2 root 2. Okay, and then finally 2 root 2 times minus 3 root 2 will give me minus 2 root 2 times 3 root 2. Okay, so this will end up as 10 minus 15 root 2 plus 4 root 2 minus, we're going to have 2 times 3 is 6. Then root 2 times root 2, that's root A times root A will give us what? A. So root 2 times root 2 will give us what? 2. So we'll end up as 10 minus 15 root 2 plus 4 root 2 plus, sorry, minus what? 12. Minus 12. Okay, so grouping lighting, that should give us, I'm going to group 10 and minus 12, which will give negative 2. Then I'll group the sets 2, which will be, let's put it minus 15, okay, plus 4 root 2. I'm factorizing the root 2 out. So that gives me minus 2, negative 15 plus 4 will be negative 11 root of what? Of 2. And that is our final answer. So I'll take your questions, but you have question 3 for your homework, which you submit in class next week. Submit it, please take note. Submit your homework to your course rep before I come to class. Don't do that after class. So before I come to class next week, course rep, you should have all the solutions in an envelope for me, sealed. Okay, take note of that. Okay, so question 3 for your homework, you are to simplify 2 plus 3 root 2 times minus 2 minus 3 root 2. That will be your homework. Okay, so you take note of that. Okay, now let me take your questions if you have any. Yeah, so the homework, yes, for now you can do it handwritten, okay, handwritten, but subsequently you have to type homework. So let me take Osman Sauda. Osman, let's take,
Sir,
yes.
please, the fourth step, the 10 minus 15 root 2 plus 4 root 2 plus, negative minus 12.
Yes.
Please, from that place, I'm confused. 10 minus 15 root 2 plus 4 root 2 minus 12.
Okay.
Please,
So
can you?
what I did is I brought a negative 12 here. Just a rearrangement. 10 minus 12 and minus 15 root 2
Plus 4.
4 2.
Okay.
So 10 minus 12 will be minus 2. Then I apply the square root 2 out. I get negative 15 plus 4. Okay, let me take another question. Isaac. Isaac Alexander.
Please, you have answered.
Okay. I think that is where most of you have challenges. So once addressed, we can move on. Now, the next thing we want to look at is the concept of our time is so much gone. We've almost exhausted. We are left with just 30 minutes to exhaust our 3 hours. Okay. So let's clear the screen. We are looking at rationalization of set. Now, let's use examples to demonstrate that. Now we have 5 over 2 root 5. Now, when you are given a question like this, and there is only a single term in the denominator, okay, and I ask you to rationalize it, then Kelvin, Cyril, you are writing on the screen. When I ask you to rationalize this, what you do is, for this simple rational fraction, you just multiply through by, okay, the set. So multiply through by square root of 5 over square root of 5. You've not changed the expression because square root of 5 over square root of 5 is 1. This cancels this 1. So by multiplying through by square root of 5 over square root of 5, you've not changed the expression. It's still the same expression that was given initially. The only thing that will happen is when we multiply like this, it will look like 5 square root of 5 over 2 times square root of 5, okay, times square root of 5. So that will give us 5 root 5 over 2 times square root of 5 times square root of 5 will give you square root of 5 squared, which is 5. So that will be 2 times 5. So this is the same as 5 root 5 over 10. Okay, 5 root 5 over 10, which will be root 5, okay, divided by what? 2. Sorry, I wrote root 2, so this should be root 5. Sorry. sorry for the noise. So that is root 5 over 2. Okay, so you notice that when we talk about rationalization, the primary objective is to change the set. We want to eliminate the set in the denominator. We are just interested in taking away the set in the denominator. So you realize that in the long run, the denominator doesn't contain a set. That is what we mean by rationalization. Let's look at another example. So question 2, let's say I have 3 over, let's say 4 root 2. So the objective is to take away the set. We don't want the set in the denominator. So multiply through by square root of 2 times square root of 2. You've not changed the expression. So here we have 3 root 2 over 4 times root 2 times root 2, which will be 2. So this will give me 3 root 2, okay, all over what? All over 8. Now 3 root 2 over 8 is your final answer. So you notice that here there is no what? Set in the denominator, okay, which is the objective of rationalization. Now, in the case where we are given, I'll take your questions, but just follow, okay? I don't think this is too difficult. In the case where we are given 2 terms in the denominator, for example, 3 over 2 minus root 3. So here we have 2 terms. This is the first term. This is the second term. Terms are separated by addition or subtraction. This is a subtraction, so they are different. Multiplication, well, this one is multiplication, so it's 1 term. So when you have 2 terms as your denominator, what you use to rationalize it is you have to fall on the conjugate, okay? So the conjugate means you are just going to rewrite the same set, but you change the sign in between them. So instead of subtraction, use addition. So that will be addition of 3. Okay, so let's do that. We're going to multiply through by the conjugate, which will be 2 root 3 over 2 plus root 3. Okay, so this will give us 3 times 2 root of 3 over 2 minus 3 root 3 times 2 plus root 3. Okay. So when we expand this, 3 will multiply 2. That will be 6 plus 3 will multiply root 3. That will be 3 all over 2 will multiply 2 will give us 4. 2 will multiply root 3. You have plus 2 root 3. Then minus 3 will multiply root 2. Let me clean this first. So negative 3 will multiply 2. That will be minus 2 root 3. The negative 3 will multiply root 3. That will be minus root 3 square. That will be root 3 times root 3, which will be 3. So this gives us 6 plus 3 root 3. Okay, all over 4 minus 3. This is the 3 I'm talking about. So root 3 squared is 3 plus 2 root 3 here minus 2 root 3. 2 root 3 minus 2 root. If you factorize, it will be 2 minus 2, which is 0 times root 3. So this side will be 0. Okay. So this will give us 6 plus 3 root 3 all over what? All over 1. So once it's over 1, there is even no need writing the 1. So our final answer will be 6 plus 3 root 3, meaning we have deleted or we've taken away what? We've rationalized away the root sign from the denominator. Okay, so now observe the questions carefully, and then if there are any questions, you can ask. Okay, so let me take questions. I have Vincent Ado. So Vincent Ado.
Yeah, so mine is not directly to the work there. I just wanted to ask before it's too late. Regarding the assignments that you gave, I only have hand on one, the third one that you just gave. It means the first and second one, I don't really have it. So whilst we are before the class ends, so that please let me get it. Yeah, it's not directly regarding to what we are doing now. Thank
Okay,
you.
thank you. It's in the video, you see it. So when you watch the video, you write out the question. Yes, Felix or say.
Yes, boss. Please, how do you manage to get the root 3 square? Can you hear me, sir?
Yes, I can hear you. Root 3 times root 3 gives you root 3 squared.
Okay. Okay, thank you, sir.
You're welcome. Okay. So with that understanding, let me get you a question from this section too. So let's have a question. I'm going to give you want to rationalize 2 plus 2 root 2 over 3 minus 4 root 3. So that will be question 4. Then question 5 will be to simplify simplify, let's have 4 minus, no, 4 root 192 3 root of 12. Then lastly, which is question 6 here, we have to simplify 2 root 2 plus 3 root 3 times 4 minus 4 3. Okay, so these are additional 3 questions. And as said, so having captured that, we want to go on to logarithms. Okay. So on logarithms, so we are on logs. Don't worry, your hand is for the question. The questions will be in the video, so don't worry at all. So, oh, Efria, you are disturbing my screen. Yeah, so logarithms. Basically, a log function, okay, is the inverse of an exponential function. We usually write logarithm to the base a of a certain number is equals to a certain value x. Okay. Yes, and what we mean by this is let's just take examples. So if I write this, it's also equivalent to n. The number is equals to a raised to the power what? Okay, the base raised to the power the given number x. Okay. So this is what it means. This is exponential. This is logarithm. So anytime we have this exponential, it can be re-expressed by just what? Finding the log. When I find the log to a base, say a sides, I find the log to the base a of what is written here. Okay. Now this will give me log n to the base a. Okay, and then this side will be equal to x. Why? Because log of a to the base a is always equal to 1. Okay. Very good. So let's need to understand some few rules of logarithms. I think what I'll do is I'll give you the rules of logarithms. The next time we meet, we'll see, because time is fast spent. So the first rule is the multiplication rule, which is log to the base a of the product of two numbers, p times q, which you write this down, is equals to log p to the base a plus this side. Okay, so plus log to the base a of q. Okay, that is the multiplication rule. The next one has to do the division rule. The division rule, which states that you have log to base a of p divided by q. We are going to get log p the base a minus log q to the base a. Okay, so I think we also looked at the fact that log a to the base a is equals to 1. Okay, log a to the base a is equals to 1. And we can also write log n to the base a can also be written as log of n to the base b over log of a to the base b. So these are the basic principles of logarithms. Now let's see some very basic examples related to what we just looked at. For the first, for the multiplication rule, we can have a question like, we want to find log of, say, 6 times 9, okay, to, let's say, the base, or better still, I want to change this. So let's have log 3, okay, 9 to the base 3. When we expand this should give us, per the rule here, this should be log of 3 to the base 3 plus log of 9 to the base 3. This will give us log 3 to the base 3 per this rule here. Log a to the base a is 1. Okay, plus log 9 is the same as 3 squared. Okay. But this can be re-expressed as 1 plus 2 log of 3 to the base 3. So we know from the rule that log 3 to the base 3 is 1. So we have 1 plus 2. And the final answer is equals to what? 3. Now, another way to just cross-check this is log Log 3 times 9 is what? 27. Now 27 is the same as 3 raised to the power 3 raised to the power 3, which can be rewritten as 3 log 3. Now log 3 to the base 3 is 1. 3. So these are two ways in which we can get our answer. But for the verification of the rules, I prefer we use what? This steps. Okay. Now let's take another question. Let's say a question like still related to the addition. Okay. So we want to have a question like I think it's straightforward. Let's just take one on division. Let's say we have log a to the base say 6. Okay. Log 3 log 6 to the base 3 minus log of 2 to the base 3. Okay, when we look at this, it follows this rule. So it means that we are going to divide our P. This will be the P and this will be the Q. So we divide the P by Q, knowing that we have a common base of A. So this will be log now P is 6, Q is 2, then the base is 3. So we end up getting log of 6 divided by 2 is what? 3. So log of 3 to the base 3, which will still give us equal to 1 per our third rule here. Okay. Now, for the last rule, which is log of n can be expressed as another in the form of another base. If I give you something like log 27, okay, to the base 2, what this rule is saying is this is the same as log 27 to, I can use 27 to the base, change the base, which is base 3, to log of 2 to base 3. Okay. So meaning that you change the base from A to what? To B. Then your n here becomes your numerator number. And then the base here becomes the denominator number. Okay, so it's the same thing. This is our n, and then this is your A in the formula. Okay, good. So we can easily simplify that to get our answer. Okay, I think there's some hands up. I'll take those questions. I have Sawada Osman. Sauda Osman.
Sir, please, no question.
Okay, then lower your hand. Bernard Bismarck Nyako. Bismarck Nyako.
No question, sir, please.
Lower your hand.
Okay.
Aqua Solomon.
Yeah, sir, please, about the question 1.
Yes.
I had a little problem there. Yeah. I never understood. Okay, from like, I mean the code. Yeah, I never understood.
What is the problem? You need to, question 1 is no more on the board. So what was the problem?
Yeah, I mean from log 3 times log 3. I don't know how to mention it. Log 3 times 9.
Yes. Yeah, so if it is 3 times 9, this is it. 3 times 9. Rule 1 says that just use this expression. That will be log 3 to the base 3. Then log 9 to the base 3. That is what the rule says. Okay. Now,
Okay, sir.
responded with the rule.
Yes, sir.
Log 3 to the base 3. This is it. Log a to the base a is 1. So this will be 1. And then log 9. 9 is the same as 3 raised to the power 2. And anytime you have an index raised to the power 2 and the logarithm is applied, the index will go in front. Okay, so just right, it's the same as 2 log 3 to the base 3. Then log 3 to the base 3 per this rule is 1. So the final answer will be 1 plus 2.
Okay, sir.
So I'm going to write this. So anytime you have something like this, log of, let's say 3 to the power, let's say 20. No, we've already looked at this, so I don't want to use this one. So log 2 log to the base 2 of say 64. Okay, 64. You see, because you already have a base of 2 here, you want to express the 64 in terms of what? The same base, so that at the end of the day you get log 2 log 2 of 2. That one we always know it is 1. So without a calculator we can easily find the value. So 64 is the same as 2 raised to the power 6. So that will be 2 raised to the power 6. Okay, to the base 2. Now, as I'm saying, once it is exponent here and the logarithm is there, this 6 will come up here. It will come in front. So you just write it as 6 log 2 of 2. But we all know that log 2 of 2 or 2 to the base 2 is 1. So you end up getting 6 as your final answer. Okay, that is what I was saying. Okay.
Thank you, sir.
So finally, our time is fast spent though. But finally, I have a question here. We have, yes, beautiful. So if I have a question like, let's go back to our exponents. We have a question like, somebody is writing on the board for no reason. If we had a question like 2 raised to the power x is equals to 3 squared. Remember, somebody asked, oh, who are those writing on the board? So somebody asked this question that, what if the bases are different? So when bases are different like this, we always know that if you want to bring an exponential power down, just introduce the log. Okay, so we can introduce logarithm here. So when we introduce log, let's say log to the base 2 here, it will look like this, 2x, then you do the same thing on the right hand. So log to the base 2 of 3 raised to the power 2. So when we do this, the exponent will come in front. That will be x log 2 of 2. Okay, is equal to log, then this one to the exponent will come. That will be 2 log 3 of 2. Okay, and then this will give us x, because log 2 to the base 2 is 1. Then this will give us 2 times log of 3 to the base 2. Okay, so that will be our final answer, okay, for such a question. Now I have a question for you. I want you to try at home. I want you to solve this equation. So that will be your 7th question. Log a to the base x plus log of 27 is going to be a challenging question, but think through it carefully. When you come to class, we will address it. So log of 3 to the base x, and then log 27 to the base x equals to 2. You are supposed to solve for x. Okay, so think through it carefully, and you get the answer. Yeah, so on that note, we'll summarize what we've done so far. We've looked at indices, the rules, and then examples looking at initial equations. We've looked at sets, addition of sets, multiplication, and rationalization of sets. And then we've looked at the rules of logarithms and solve some examples in relation to the rules of logarithms. We'll bring the class to a close here. So we'll end our class for today here. I didn't ask you to leave class. Okay, so let me quickly take my attendance, very important. We're supposed to have a number of people. So what you do is type your name. Some of you, now those of you who did not come with your actual name into the class, just you are the ones I need you to type your names for me. So I have Wahab Asari in class. I have Wahab Asari. I have how do I get this thing going? So Wahab Asari, Isaac B. John. I have Ibrahim Kadi. I have Wise Kotoku, Aaron Tete, Abanga Michael, Abdallah What's happening? Please stop raising your hands. Wahab Asari, Isaac Nyana, Deborah Odro. Please stop raising your. I'm taking attendance. Michael Amedo Abanga Michael. I have Abdallah Wonpini. Okay. I think I can take a screenshot. Okay. So let me take a screenshot. Attendance. So and this time we'll be working with attendance very much. You don't want to miss a class. So I'm going to capture it with the screen capture so it will be easier.